Hello everyone, this is Chris Ferrigno. This is the final lecture in 504L. Today we'll be talking about the thorax, abdomen, and the pelvis. I know that you are very upset that this will be the last time you have to sit through these extremely difficult lectures. So let's begin. We're going to start today by talking about the heart, and then we will move on to the lungs. So here we see a heart, and as you notice, it vaguely represents a heart that we might draw, let's say for Valentine's Day. However, you notice that the tip of the heart is shifted off to the left side. You're right, but the person's left side. So if we were to really draw the heart, we should probably draw it something like that. Here are the learning objectives for the heart, and I'm going to have different learning objectives for each subsection. So here we have a picture of it's generally the thoracic cavity. We're missing a few structures here, primarily the bony cage of the thoracic cavity. As you can see, we have some indentations here for ribs. Might give you an idea of where they sit. We have this diaphragm that underlies the thoracic cavity and overlies the abdominal cavity. So your abdominal contents would be here. Your liver would run something like this, and your stomach or your esophagus will be coming out roughly right here. Here we see the esophagus as well. Esophagus comes, and then we have a stomach. We'll be talking more about that in a little bit. Maybe over here we'll have a spleen, and then of course the intestines in this area. So we have this diaphragm that separates the abdominal cavity from the thoracic cavity. Here we see that tilted heart. So we have that apex of the heart again over in this direction, and outline this heart here. This is generally called the mediastinum. You don't need to know that, but this would generally be called the middle mediastinum, where the heart rests, and then this would be the superior mediastinum up here, and then we'd have an anterior mediastinum and a posterior mediastinum. And that's basically the heart cavities and the areas around the heart. And then to the left and right of the heart are the pleural cavities. So here we have a pleural cavity on the right. And this pleural cavity is covered in what's called pleura, which are this blue that we see here, the light blue, and that's your pleura, and that contains your lungs. So we have a right lung on the right, and we have a left lung on the left. And we'll clear that out so that we can see the innervation to the diaphragm. So right here would be the phrenic nerve. It's really pointing to this yellow structure there. And that phrenic nerve is going to travel down. I believe we saw that in the neck. It's going to travel down right by the heart and then innervate the diaphragm. We have a left and a right one. Picture in the upper left, we can see the contents of the thoracic cavity. In other words, we can somewhat make out the heart here and the lungs. You can see now, we can see that bony cage and the sternum. You can see that that heart rests nicely behind that sternum. It's well protected behind that sternum and the ribs, as are the lungs. What you might want to notice here on the left picture, let me see what color, maybe go with yellow, that we can see this diaphragm extending up pretty far up into that rib cage. So what that means is again, we're going to have abdominal contents protected in part by the inferior margins of these ribs. So let's take a global look at the systemic and pulmonary circulation. So in the middle here we have obviously a heart, and we have a right side of the heart, and we have a left side of the heart. As you can see, the right side of the heart is going to be responsible for taking blood in from the systemic circulation. It's going to travel up this way. It's going to go into the upper chamber of the right side of the heart. It's going to travel into that chamber. This chamber is called the atrium. It's going to travel into the right ventricle, out of the right ventricle. It's going to go to the lungs. Blue means deoxygenated blood. So this deoxygenated blood is going to have lots of carbon dioxide. It's going to drop off its carbon dioxide in the lung. It's going to pick up some oxygen. Now it's become oxygenated. And that oxygenated blood now needs to get pumped to the rest of the body, including the brain. We're going to go into the left atrium, down into the left ventricle, and it's a little hard to see here, but it gets shot out into the aorta, where it's now going to go into the systemic circulation, bring all this beautiful oxygenated blood to the rest of the body, everything except for the lungs, including the brain, and then it'll be used. It'll collect carbon dioxide and it'll take that path all over again. So most of what you need to know about the heart is all on this one picture. And I don't love to teach off of almost cartoonish illustrations, but it's okay. I think it does a pretty good job. So again, here in green, we have this systemic circulation return. So spent blood, again in blue, is going to come in through the superior vena cava if it came from the arm or the head, or the inferior vena cava if it came from any structure relatively below the heart. This blood comes into this atrium, and gets mixed together, and then gets shot out through what's called the right atrioventricular valve, also known as the tricuspid valve. Okay, now it's going to go into that right ventricle from the right atrium, and this valve is now going to close, and the right ventricle is going to this wall. This wall is going to contract, and it's going to express that deoxygenated blood up into the pulmonary artery. And then we have a split here that blood can go right or left into a left pulmonary artery or a right pulmonary artery. Of course, it's going to go to the lungs. So it's going to go to the lung this way and go to the lung this way. And then it's going to get oxygenated. And this should really be red here, but these are your pulmonary veins. Now, this is one of the few exceptions where a vein has oxygenated blood, and over here, the artery had deoxygenated blood. So we have this oxygenated blood that's going into the pulmonary veins, into the left atrium, now through the mitral valve, or the left atrioventricular valve. So obviously most of us have heard of this mitral valve. It's going to go through the mitral valve closes, and then blood is shot back up now into the aorta, up this way, and either around and down into a descending aorta. This is an ascending aorta, this is a descending aorta, and this is the aortic arch. It can go around this arch, or it can start going up into one of 3 different passageways. We'll skip over that for now. One thing I neglected to mention was that on the right side, over here, is a pulmonary valve, also called a pulmonary semilunar valve. And similarly, right here is the aortic valve, also called the left semilunar valve or the aortic semilunar valve. So let's take a bit of a more realistic look at these structures. So again, we have the apex of the heart over here. So this heart is kind of tilted off to this person's right side. So we have generally a ventricle over here and a ventricle over here, and we have an atria generally in this area and another atria generally in that area. So we call this the right ventricle and the left ventricle, and then we would call this the right aorta, or the right atrium and the left atrium. Okay, again, here we have the inferior and superior vena cava bringing blood into this atria, this way or this way. We have the right ventricle expressing blood up out this pulmonary trunk, where it can decide to go right or left to the right and left pulmonary arteries. Then we have the left ventricle expressing blood this way out into the aorta. And again, 1, 2, 3, or 4 options for that. And what else do we have here? In the back, it's very hard to see, but we have some pulmonary veins where oxygenated blood, we don't see them on the right side. I'll just kind of point to kind of where they would generally be. But this right here is not a pulmonary vein, that's a pulmonary artery. Okay, so we've flipped the heart around. We're looking at the posterior side. So from this posterior side, something to note, we now see a much larger left atrium here. When we look posteriorly, and we can see a different viewpoint for this right atrium, kind of in this area here. And so then we get to see a really good look at these pulmonary veins going in that direction. Otherwise, everything's relatively redundant. Something I should note, if you see something in this color right here, it's an item that you should know. If you see something that's grayed out, something like this, it's something that I've left in, again, for completeness, but we're not going to discuss it, and you don't need to know about it. So this is largely redundant. We've just turned the heart, shifted a little bit, rotated a little bit, so you see more of the left ventricle down in this area. Change my color. Left ventricle down in this area, and then we get to see a little bit of the backside of the right ventricle as well. Now, this is a view, this is the internal view of the right ventricle. Don't let this freak you out. As you can see, most of these structures are grayed out, but we're really looking in the right ventricle, the chamber of the right ventricle, so blood would be filling this whole area in here. How did it get in here? Well, it came this way from the right atrium through this, what looks like a parachute. It came down through this tricuspid valve, and now the blood resides in this right ventricle and is going to get kicked out this way through this pulmonary semilunar valve, which has been opened up so that we can see what it's made up of, which are these 3 semilunar structures. If we take this end right here, wrap it around to this end, bring them together, approximate them, now we would have a pipe, and we would have this structure that can close very easily and prevent backflow of blood. So now we want to give the left side its due, and we can look inside the left. Actually, we're looking in the left atrium here and the left ventricle. And of course, this blood from the left atrium is going to get pressed down through the mitral valve. You ever wondered why it's called a mitral valve? Well, take a look at this shape. Something like this. And then on the back side, have something similar, right? Well, it kind of resembles the mitre hat that the Pope wears, which I think is a pretty cool little story. So as you can notice here, everything here is grayed out. All you need to know is the name of this valve is the mitral valve. So that's also the left atrioventricular, the left AV valve, or the left atrioventricular valve. And then, of course, this blood that's residing in the left ventricle is going to get shot out this way. It's hard to see. It's going to get shot out of the left aortic valve into the aorta itself. So this is a top-down view, and what the artist has done, the illustrator has done, is remove the atrium. And so we're looking down onto this left atrioventricular valve here and the right atrioventricular valve here. So this is posterior, this is relatively anterior on the heart. So you can see that the AV valves are relatively posteriorly situated and the semilunar valves are relatively anteriorly situated. So this just gives a good view of what happens when we are in what's called diastole. You don't need to know this, but this is when the heart's at rest and the ventricles are filling. So actually, excuse me, this is systole because the ventricles have contracted and are expressing blood out of the pulmonary artery and out of the aorta itself, this being the aorta. And then down here is the heart in diastole, where the ventricles, the large muscles of the heart are, I spelled this wrong, this is an O, diastole, where the large muscles of the heart are relaxed. And you can see that the valves are closed here. The semilunar valves are closed, but the AV valves are open, allowing blood to flow into the ventricles so that then they'll close. These valves will close and the ventricles can contract, and then these valves will then open and you'll look like that again. So there's lots of information on this slide, almost all of which you do not need to know. I just left it in there in case you're interested. But the take-home message from this slide is that if you have faulty valves, you'll end up getting some sort of backflow and turbulence, and so you will have a decreased blood circulation, which can give you many different problems in life. So of course, the heart itself needs blood to survive, and it's working all the time. It's beating approximately once a second, so it's very active, and it needs its own blood supply, and it gets its own blood supply selfishly. First, it takes its blood first before anything else gets that wonderful oxygenated blood. So this is how it does that. So here we see, let me get another color. Here we see the aorta. And so as you might imagine, this aortic arch is going to come around this way. as this blood gets expressed, the blood shoots up. Some of it falls back down and rests in these now closed semilunar valves over here. And there's one little hole in the semilunar valve over here, and there's one little hole in the semilunar valve over here, and that blood comes into the left coronary. So this is the left coronary artery from here to here, and the right coronary artery, which goes from here and wraps all the way around the back of the heart. And so here we see that right coronary, it's wrapping around the back side of the heart. So basically you just need to know that there is a right and a left coronary. Okay. And the right coronary is rather long. I don't know how long, maybe 3-4 inches. The left coronary, well, maybe even longer than that. So let's say 3 to 6 inches. I'm not quite sure. The left coronary is very short. It's around 1 centimeter long. Okay, so let's move laterally from the heart to the pleural cavities and the lungs themselves. So it's going to be quite easy looking at the lungs. We're just going to look at the two lungs, the right and the left, their corresponding lobes. We're going to look at the root of the lung and see how things get in and out of the lung. And we're going to look at this tracheobronchial tree, in other words, how the air gets in and out of the lung. So here we're looking at a right lung. We're looking at the medial surface of the lung. We know it's the medial surface here because this is the area I like to call the business district. This is kind of like you drive into the loop and there's things coming and going in every which way. So a lot of crazy stuff happens inside this business district. That's called the root of the lung. Okay. And that's pressed up right against the heart. And anteriorly, we'll call this anterior. We'll call this posterior. You'll notice anteriorly that the anterior margin of the heart, this is kind of curled around right here. So this is what I like to call the sharp edge of the lung. It's quite sharp when you first pull it out. And then back here, this is a really rounded, the posterior side is the dull edge of the lung. Okay. And then we have the diaphragmatic surface here. This sits right up against that dome diaphragm. And then, of course, we have the apex of the lung up here. So you hold this lung in your hand, and you can tell that it's a right lung because you find the sharp edge. You put that facing forward. You find the root of the lung. You find the root of the lung. You put that facing inward, and you put the apex of the lung up, and you know that you're holding a right lung. We'll do this in lab. So note that in the lung, normally we have an artery. Sorry, I'm going to change my color. We have an artery that is typically higher. I like to say that the artery is closer to the apex of the heart, while the veins are lower, generally speaking. And then we have an airway that is the airway over here is generally posterior to the artery and often posterior to the veins as well, although we don't see that in this picture. So also note in a lung that we have, at least in the right lung, we have 3 lobes. So let's label these lobes. We have an upper lobe or a superior lobe. Okay. We have a middle lobe way over here. So we'll call this an upper lobe, a middle lobe, and a lower lobe here. And the lower lobe is quite large, so it extends all the way up there. Again, this is on the medial side. It looks a little different on the lateral side. So now we're looking at a left lung. Again, we'll play a little game here of finding the sharp edge. Okay, that extends all the way down. And then, of course, we have the dull posterior edge. Again, that sharp edge was anterior. This is the dull posterior edge. We have the apex and then the diaphragmatic surface. Okay, on this lung, we have a upper lobe and a lower lobe, and that's it. Only two lobes. And then we have this structure called the lingula. Well, lingula means tongue, and hopefully we can see in lab that many of the upper lobes have this extension called a lingula. All it is a piece of lung. It's a piece of the upper lobe of the lung. Okay, let's turn our attention to the root of the lung. And again, here we have an artery on top. We have the veins below, and generally speaking, we have this airway, the bronchus, the airway posteriorly. Okay, so now we're looking somewhat anteriorly. We are looking anteriorly, and here is the anterior sharp edge that I mentioned on both lungs. The take-home message here is that the lungs look quite different laterally than they do medially, but obviously the lobes don't change. We still have an upper lobe, we still have a lower lobe, we still have an upper lobe on the right, and a middle lobe and a lower lobe on the right as well. Here's that lingula, and this picture doesn't look like much of a tongue. Sometimes they really do. And what's hard to appreciate is that root of the lung in here, but we can see the airway coming in. So, as you might imagine, the mouth is way up here, maybe even higher, and air has gone in and down the windpipe, which is now called the trachea, and air gets to choose to go one way or the other down into the primary bronchus. I should say a primary bronchi, or a right or left primary bronchus, and then it gets to choose to go into secondary bronchi. And these secondary bronchi will take the flow of air into various subsections of the lung. So just a somewhat significant clinical note here, as things traveling down the airway other than air, such as your 2-year-old child's marble that decides to roll, go into the mouth and then get swallowed and get aspirated into the airway system. It's going to travel downward, and that marble gets to go into the left or the right bronchus. And let's turn our attention up towards the upper left here, where that marble is coming down. It gets to choose, and there is a steep turn off here or a more gradual turn off here. This is generally narrower than this side over here, which is usually wider. So the marble most often goes to the right side. So that does it for the thorax. So let's do a quick review. We talked about the heart. We talked about 4 chambers, a couple large vessels, so the great vessels. We talked about the cardiac vessels. I believe that was a right and a left coronary. We talked about some valves. Right, we had 4 valves. What else did we talk about? We talked about 2 lungs. The right has 3 lobes. The left has 2 lobes. And well, let's move on to the abdominal wall. So let's move on to the abdominal wall. So the abdominal wall is extremely important to discuss because it's an extremely important set of muscles. Number one, it gives us some major support, helps us with respiration, obviously helps us with movement, and of course it makes us look good on the beach. So there's some aesthetics to that as well. Before we actually talk about the abdominal muscles, we should probably discuss some of the attachments for those muscles. So here we see some of the attachments. We see the iliac crest that you're quite familiar with at this point, the ASIS. Many of these muscles are going to extend down and ultimately insert into the pubic symphysis or somewhere in this pubic region, and it'll even insert and contribute and form the inguinal ligament. We also have vertebra. The only reason why that's grayed out is because we're not going to revisit the vertebra, especially on the practical. So I didn't want you to get freaked out and say, "Oh my gosh, we're going back to that." But it is a point of attachment for some of these muscles. So this is saying basically the same thing, but it now introduces the rib cage, and so the muscles are going to have some big attachments here on the costal margin of the rib cage, xiphoid process here as well, and of course one of the roles that I didn't mention earlier is that these muscles are going to protect. So they give an added layer of protection to the abdominal viscera that's going to be located deep to them, all the way down. So here we see some surface anatomy, and what's obvious here on the right hand side for someone who has relatively little body fat would be the midline musculature, so the rectus abdominis. Obviously, this individual has what we call a six-pack, 3 on this side and 3 on this side. And then laterally, we're going to see some other musculature that we're going to be focusing on here in the next couple slides. So superficially, we can see muscle fibers running in this direction, which is your external oblique muscles. And of course, superficially, we can also make out the umbilicus. Notice that the external oblique muscles, imagine you put your hands in your hoodie pocket. So here's your thumb, here's your fingers. They're in your hoodie pocket on that side. They're in that same, the fibers of external oblique are running in that same direction. Okay, so here we see a cross section of the abdomen. And so this is anterior, this is posterior. Of course, this is a vertebral body here. And this is what would be your abdominal contents in here. And this is your aorta. So anteriorly, of course, we have that rectus abdominis, part of your six-pack. And then over here on the side, we have 3 muscles. We have that external oblique most superficially. We have this next one, which would be the internal oblique. And then we have the transverse abdominis muscle. So from superficial to deep is here. We have external oblique first, and then internal oblique, and then transverse abdominis muscle. Okay, so here's what it looks like in a cadaver. Again, the hands in the pocket, we have the fibers of external oblique going at this oblique angle downward. Now, we should see fibers of the internal oblique going relatively in the exact opposite direction. Now that's going to vary depending on where you see it. So if we go now, again, we go on the right hand picture, we have that same external oblique on this side, but now on the left side, on the person's left side, but on our right side of the picture, the external oblique would be going in this direction, and now we see the internal oblique going relatively opposite direction that way. I think I've exaggerated that direction a little bit. So once again, we have the external oblique, and then here would be the external oblique on that side, but we have the internal oblique go in this direction. And let's take a look on our far right, this person's left. And again, here's now the direction that we would see the internal oblique. But if you notice very carefully, the transverse abdominis, this is going to be transverse abdominis. It's a slightly different direction. Now, as you get more superior, the internal oblique tends to run a little bit more diagonal, more like this. So we would have on this side, shift your attention to your left just a little bit. So let's draw the external oblique in blue. You don't really have to because it's right there. And then let's make an internal oblique in green. The internal oblique in green should be about like this. That would be deep to the blue. And then deep to both of those would be transverse abdominis coming in that way. As you get down lower, real low like here, the transverse abdominis is running in that direction, and the internal oblique is pretty much running in the same direction. So it's much easier to tell way up here somewhere of those fiber changes. Okay, so let's take a minute to talk about what these muscles do. So let's start with the rectus abdominis. So here we see ribs. Kind of make out maybe another rib, maybe perhaps under there. It's hard to say. But the ribs are under there. So it's attaching to the ribs. It's attaching to this fibrous tissue underneath the abdominals. Not so important there. But distally, these rectus abdominis are going to come in and attach onto your pubic symphysis on both sides. Okay. So if your trunk, let's say actually if your pelvis is fixed here, let's say like you're going to be doing a sit-up and you've hooked your feet up underneath a sofa, so your pelvis is relatively fixed and your abdominals contract, shorten, in other words, it's going to pull your ribs closer to your pubic symphysis. Well, how the heck can that happen? Well, you're going to have to curl up a little bit. So you're going to take what's normally a lordotic lumbar spine, and you're going to put a little kyphosis, or you're going to put a little back forward bend into your lumbar spine. Okay. In doing so, your pelvis is going to probably rotate posteriorly. Now, let's say you're lying on the floor and your legs are free, and you want to try to bring your legs up over your head from a supine position. So you're going to contract your rectus abdominis in this direction, and it's going to pull on your pelvis, and now you're going to again curl your lumbar spine or flex your lumbar spine. So in other words, rectus abdominis is really simply a trunk flexor, is simply what it is, or a posterior, gives you a posterior pelvic tilt. Okay, so what about the obliques? Well, the obliques generally help you with rotation. So the right oblique, when it contracts, it will help bring your right trunk, your upper right trunk, over to the left, as does your left internal oblique is going to help you bring your right trunk over to your left. Now, conversely, if we had some obliques on the external obliques on the left and internal obliques on the right, it would help bring your left trunk to your right. Does that make sense? I hope that makes sense. What does your transverse abdominis do? Your transverse abdominis is running generally in this direction. It acts as a stabilizer for your lumbar spine. So the transverse abdominis muscle equals a stabilizer. Very little actual motion, more just stabilization. The right external oblique and left internal oblique gives you left rotation, and vice versa. So I'll let you try to figure out which muscle is which, and simply delete the pink box here at the bottom to see if you were right. So these muscles in the abdominal area get innervation from the intercostal nerves of T7 through L1. Okay, and that will leave it at that. So we'll just call these intercostal nerves. And these intercostal nerves run or course between between internal and transverse abdominis. So here we see a lovely picture of these intercostal nerves. Somebody did just a magnificent job dissecting this. No, it wasn't me. Coursing on top of the transverse abdominis muscle right here. So both the external oblique and internal oblique were stripped away. Okay, so let's now take a closer look into the abdominal cavity. Okay, so we're going to try to keep this relatively simple. So you take a bite of food and you swallow it. It goes down your esophagus and into your stomach. Sits around for a little while, gets churned by the stomach. The stomach's got a lot of muscle to it. Gets some acid in there as well, hydrochloric acid. Breaks it down a little bit further. And enzymes break down the sugars. Alcohol gets absorbed. A few other things happen. And now this food gets really broken down well here, and it goes into the duodenum. So this is generally the junction from the stomach into the duodenum. And there was a sphincter there. There was a smooth muscle that helped prevent food from going into the duodenum until it was ready to go, at which point the sphincter relaxes. The food then goes into this duodenum, and I'm coloring it green here. Call that the end of the duodenum. It goes into the duodenum and it's green because there's stuff being released into the duodenum. In other words, bile got released in by the liver, went into the, sorry about the color there, it went into the gallbladder for storage and then got spit back out, kind of traveled roughly through the pancreas and then gets dumped into the duodenum. And this bile helps really break down the food a bit more. And now we start the absorptive process, so where a lot of the goodies are getting absorbed into the body. So we're in the duodenum, and we've traveled now this way, and now over here on the left hand side, our right hand side, is the jejunum. Okay, so the jejunum is quite long, and so goes around the jejunum. I'm kind of making up the route here. Okay, and then at some point, there is not a defined transition. It goes now into what's called the ileum, and then it travels around the ileum, at which point the ileum dumps into the cecum. So where's the ileum? There's the ileum. Should probably color the cecum a different color here. So now we have the cecum as the beginning of the large intestine. So we have the duodenum and the jejunum and the ileum as the small bowel. And now we're going into the large bowel with the cecum. Okay, so food now goes up the ascending colon. Why is it ascending? Of course, it's really traveling up the body at this point. It takes a turn around the hepatic flexure. Why hepatic? Because that means liver. It's close to the liver. It goes along the transverse colon to the splenic flexure. Why the splenic flexure? Because there's a spleen over here. Down the descending colon, around the sigmoid colon. You can see why it's called the sigmoid colon. Into the rectum, and then out the anus, of course. So this is similar, but just shows how everything gets jam-packed up into the abdominal area. It also helps to appreciate how things are relatively protected by the rib cage, at least the upper parts of the stomach. Of course, the spleen way in the back here, and much of the liver is protected by the ribs as well, as is parts of the gallbladder and very small portions of the large and small bowel as well. So here we can appreciate just how deep this esophagus going into the stomach is, and we can tell approximately the size of the stomach, but we'll see this in lab and get a much better view of the stomach as well. And then right in this area is that pylorus, or that sphincter of the stomach, that's going to restrict food going into the duodenum. I'll outline the duodenum here. It's going to restrict food going into that duodenum until the food is ready. And so here we see the C-shaped duodenum that's going to extend back over posteriorly and way over here to the left before it turns into the jejunum, as the jejunum takes a turn around here like this. Of course, we see the liver and we see the gallbladder that's tucked up inside the liver. Of course, we can get a little peek at the ascending colon, the transverse colon, and the descending colon. So here we see the duodenum, that C-shaped duodenum. We also can see this common bile duct. Again, this common bile duct is going to be bringing bile from the gallbladder that was produced in the liver. The gallbladder was just storing it and concentrating it, but that bile travels down the common bile duct and it extends down. I guess I should change my color there. Extends down, and it really passes. This bile duct passes into the pancreas, where it meets up with the main bile duct over here. Excuse me, the main pancreatic duct. It meets up with the main pancreatic duct, and both of them end up spilling out in this area into the duodenum. This is again the same thing. Here the bile was produced. It gets up here to stored in the gallbladder, and then the gallbladder releases it at some point and gets pushed into the duodenum via the pancreas, which we don't see here, but here we can see the main pancreatic duct that joins up with the bile duct. So this is the single slide we have for the urinary system. And this is our final slide. So, what is the urinary system? Of course, it's a way that we filter blood and we bring out some of the minerals and other parts of the blood, and we take that out, including fluid, and we discard that as waste. So, what is the pathway for that? So, certainly we need an aorta here because we need blood. So, blood's coming down, goes into a renal artery one way or the other, into the kidney, and filtration, cleansing takes place. Um, there is a reabsorption of fluid, and that fluid needs to get discarded, so it travels down a ureter into the bladder, and when that bladder fills sufficiently, it's covered with a muscle called the detrusor muscle. I think it's probably good for us to stick this in here. It's called the detrusor muscle, and that muscle contracts and helps to expel urine out of the urethra after um, a few sphincters need to relax in the urethra. We have an internal and external sphincter, and those relax, and your urine can go out the urethra. So just to review, we have the aorta, which brings blood into the renal artery, which brings blood into the kidney, which ends up filtering the blood and delivering urine into the ureter, which ends up going into the bladder, urinary bladder, and which goes into the urethra, and that goes out. Well, that completes this lecture and all the lectures for OCC 504L. I want to thank you all for tolerating me and these lectures. I hope I didn't bore you too much. You guys have been wonderful, and I look forward to seeing you in lab next week. Bye-bye.